Welcome back. This is the final lecture of week 4. In this lecture, we're going to be covering energy estimating methods. So what is an energy estimating method? So the main aspect of an energy audit is to calculate the amount of energy being used. So somehow we have to have some sort of method on establishing how much energy something specific is using, or how much energy might be saved if something is changed. So depending on the circumstances, this can be difficult because of the number of variables impacting the energy usage. To name a few, at the bottom, the obvious ones are the difference between outdoor and indoor air temperature. But added onto that, we have ventilation requirements, variation in internal loads, variation in efficiency in HVAC equipment. We have variations in the use of production equipment, variations in the use of a combination of artificial and natural lighting. So if we actually look at the potential variables here, they can be quite numerous. So we categorize the ability to go out and calculate how much energy is being used into 3 major types of calculations. The first one is the simplest form. It ends up as a result in doing some sort of hand calculation. They're typically used to quickly do a hand calculation to see if it's going to be financially viable to spend more money in doing a more elaborate calculation. So it's meant as a screening tool. So this level 1 calculation is known as a steady state method. Steady state methods, the hallmark are they decide on one variable, a single variable. So I listed a bunch of the different things that can impact energy usage. So in this method, we're singling out one thing to be the variable, and the most prominent of these variables is outdoor air temp, so the changing of outdoor air temp. If we look at the steady state methods that are available to us, there's 2 main types. One is called the degree day method, the other is called the bin method. We're going to look at these more closely coming up. The second category of energy estimating is known as a correlation method. What a correlation method is it relates one situation to a similar situation, and we'll get into that more shortly. Finally, the most complicated, and if it's done right, the most accurate, is we actually recreate the building inside a computer. So we do a computer simulation. And again, computer simulations can give us some of the most accurate information on what's happening, but it has to be done properly. I mean, all the inputs have to be put in carefully. It's the typical computer garbage in, garbage out. So it frequently takes the most time, the most money. Usually you only see them in a level 3 audit or a technical assist audit, but it does give you the most accurate information if done properly. So first of all, let's go and look at the steady state methods. So an effort to make energy estimating easy by only having one variable. Okay, you already know or realize that limiting something to one variable probably might not work for a lot of situations. So you need to understand that having a single variable has limitations. Again, that variable we're going to deal with is the outdoor air temperature. And as the outdoor air temperature changes, the amount of energy that's used changes, typical in heating and cooling. Now, a big assumption is that all other variables stay the same. This is the key problem with energy or steady state methods. The first one, like we had mentioned, is something called the degree day method. And you'll notice on this slide is how the degree day is calculated. So the number of degree days is calculated by taking, first of all, a temperature balance point temperature, and then basically you subtract the daily high from the low, divided by 2 plus the low. So that whole mess that you see inside those brackets is really the mean temperature for the day. In other words, the halfway point between the daily high and the daily low. Now, what is a balance point temperature? The balance point temperature is where a building, the temperature of the outside, where a building doesn't need mechanical heating or cooling. Now, a number of years ago, when they first started using this calculation, because of the type of insulation in the building, it was about 65 degrees out. So when you hit an outdoor air temperature of 65, most buildings didn't need either mechanical heating or mechanical cooling. That was the balance point temperature. Now, as insulation have gotten better, and for a short time more internal heat gain started happening, that balance point temperature got lower. So it dropped to 60, then 55. We even have some situations on really, really tight, well-insulated buildings where they don't need any mechanical heating or cooling all the way down to 50 degrees. So we just talked about the balance point temperature. 65 is the most commonly used, and if you go to tables nowadays, most degree day tables are still based on a balance point temperature of 65. The daily average temperature is the rest of the calculation. It's done and added up every 24 hours. So for every 24-hour period, they take the daily high and the daily low within that 24-hour period, and they calculate a mean. That mean is subtracted from the balance point temp to get the number of degree days for that 24-hour period. So following, we have an example. A building has a balance point temperature of 65. The daily high is 42. The daily low is 29. How many heating degree days do we have for this 24-hour period? So if you run through the calculation, which is shown on that slide, we get 29.5 degree days. A positive number indicates heating degree day. A negative number, which you can't really have a negative number, actually converts over. So if you calculate this out and you get a negative, it's actually a cooling degree day. You're on the other side of the balance point. So each 24-hour degree day is added to get an annual total. Values below balance point are heating degree day. Values above balance point are cooling degree day. Now it's important, this next line, and make sure you understand this. The units for degree day are degree Fahrenheit times day divided by year. Make sure you're using the annual total and not just 1 day's worth of degree day. So it's degree Fahrenheit times day divided by year. Now, most weather sites have degree day information available, such as the website Weather Underground. Now, how do we use heating degree day? They're good for quick determinations if a project should proceed. Again, we use it more for a quickie. Should I do more work on this? Should I spend all the extra time to do a computer load calc and simulation? It's used as a screening tool. Now, what the heating degree day doesn't do is it doesn't work well for certain types of equipment that have efficiency changes with outdoor air temp, such as heat pumps. Heat pump efficiencies change as outdoor air temperature changes. So anytime you have two prominent variables that are changing, the degree day method, remember, is based on one variable changing and all the other ones maintaining consistency. So heating degree day has true limitations on where it can be used. Now we have the bin method. The bin method is actually taking the degree day method and refining it somewhat. It still uses only one variable, and that's the outdoor air temp. The difference is, instead of taking just an average over a 24-hour period, in the bin method, we take a look at how many hours the outdoor air spends at a certain temperature range. Now, the ranges typically used in the bin method are 5-degree increments, or called bins. So 20 degree Fahrenheit to 24 degree Fahrenheit would be a 5-degree bin. 25 to 29 would be the next 5-degree bin, and so forth. The outdoor air temperature is taken once an hour, and that value is added to the appropriate bin. So for example, if when I went out and looked at my temperature last hour and the outdoor air temperature was 42, there would be 1 hour added to the 40 to 44 degree bin. And I would do that every hour for the whole year. So by the end of the year, I know how many hours I spent within each 5-degree bin. Here's an example of following outdoor airs were taken. So outdoor air, this is a 24-hour period. If we convert that or transfer it into the appropriate bin, we had 3 occurrences or 3 hours in the last 24 where the temperature was between 40 and 44, 3 hours between 45 and 49, and so forth. In this slide, you see an actual sample of bin data. Now, this was cut out of a chunk of information called weather data that you guys have this week in your added information. This happens to be bin data sample, and what I'm pointing to is Albany, New York. So that first column, Albany, New York, typically has 740 hours that it spends in the 62-degree bin, which happens to be 60 degrees to 64 degrees. If you look to the next column, they spend 708 hours in the 57-degree bin, 652 in the 52-degree bin, and so forth. Now, bin data can be used to calculate the number of hours spent in a specific temperature range. I'd need to know how many hours per year I could use an economizer. So let's say I know an economizer works well between a certain temperature range. If I know the number of hours I actually spend in that temperature range, I can calculate how much money an economizer could help me with. So that's an example of the use of the bin data. Another method, or method 2, is called a correlation method. What this does is this method takes existing data and relates it to a similar situation. Now, the reason this can work is many companies have been in business for a considerable length of time and have accumulated large databases of information on their product. A lot of the companies, I can go to the company's database and compare my situation with data similar to my condition. So you have to remember that this database would include a lot of different variables. So I'm actually matching my situation with a company's vast pool of information or situations to try to correlate my situation with theirs. This method differs from the steady state method because a number of variables are included. For an example, how much money will I save by adding a reflective film to windows on my building? Now, the variables by adding a reflective film could include the size of the window, the direction of the window, the latitude and longitude my building sits at, the direction the window faces, the time of the year, the time of the day, etc. You can see the laundry list of variables is up there. I don't have just a single major variable. Now with this particular example, the 3M company has been making various types of window films for ages. They have a very detailed database on energy savings based on previous applications. I can call them and give them my data, and they can compare to an existing data set for a similar building in a similar area, latitude, longitude, direction, and everything, and determine with some fair accuracy the potential for energy usage or savings. That's an example of correlation energy savings. I'm comparing one set of circumstances with a set of circumstances that I have. Finally, the final energy estimating method is the good old computer simulation. This is required for any ASHRAE Level 3 audit or full technical assist audit. The value of this is it can do multiple variables in multiple situations. It is very time consuming to get correct. Prior to use, must ensure there's money to cover the time invested to build the simulation. And everyone, at least in this class, should know how to do this already from taking the HVAC451 class. So hopefully you did well in that class. It's about ready to come back and haunt you yet for a second time. This ends Lecture 4C. You can now proceed to Assessment 4 and Exam 4. Thank you.